Hello everyone. So we are dealing with the construction chapter of class 10, right? So in the previous video we have completed the exercise number 11.1. So from today we shall start construction of tangents to a circle, and closely we will finish the chapter. Okay. Now first we have construction of tangents to a circle. Now let's see what is this. To construct tangents to a circle, you know what are tangents, right? We need to construct tangents of a circle. What are the steps of construction? All these we'll see here. Okay. You have already studied in the previous chapter that if a point lies inside a circle, suppose a point lies inside a circle, okay, there cannot be a tangent to the circle through this point. If this point lies inside a circle, you cannot have tangent from this point to that circle. Is it fine? So, however, if a point lies on the circle, suppose the point lies on the circle, if the point lies on the circle, suppose somewhere here or here, if the point lies outside the circle, then what will happen is, if the point lies outside the circle, then there is only one tangent to the circle. If the point lies on the circle like this, then suppose this point is here, then there can be one tangent to the circle and is perpendicular to the radius to this point, and the tangent should be perpendicular to the radius to that point. You see here, suppose this is a circle, okay, and then you see here, suppose this is a circle and I have one point here at this point, then from this point it should be perpendicular to the radius to this point, and then there should be only one tangent from this point. Therefore, if you want to draw a tangent at the point of a circle, simply draw the radius to this point. If you want to draw a tangent at the point of a circle, then you simply draw the radius to that point. Okay, draw a line perpendicular to this radius. You just draw a line perpendicular to this radius through this point, and this will be the required tangent. Okay, now you have also seen that if the point lies outside the circle, then there will be two tangents to the circle from this point. Suppose a point is here, okay, then there will be two tangents like this to the circle from this point. We will see this also. We shall now see how to draw triangles. We shall see how to draw the tangents. Okay, hope you understand till here, right? If you didn't understand, ask me privately, or you can ask in the comment section also in the YouTube. It's fine. What's here? Yeah, this is a circle and we need to draw a tangent. If a point lies somewhere here, then there could be only one tangent. If a point lies outside the circle like this, then there should be two tangents to the circle. If the point lies just here, then there can be one tangent like this. If the point lies inside the circle, then there cannot be any tangent. So this is the concept of tangents. Now let's see what is written here. There is a construction here. Here you see construction 11.3. To construct the tangents to a circle from a point outside it, we need to construct a tangent. We need to construct the tangent of a circle to a circle from a point outside it. Suppose this is a circle, then we need to construct the tangent from a point outside the circle, like this. Here is a point and you are constructing tangents from here like this. Then you need to construct a tangent like this. Now it's just saying that. Now let's see. We are given a circle with center O. We have a circle. Let's take a circle. Wait, I'm taking a circle. This is the circle. Okay, this is the circle I'm doing here. Okay, this is the circle. Okay, now this circle has centered O. Oh, I'm taking yellow color, blue. This okay, wait. Okay, I'm just taking a simple circle. Okay, now I'm taking a circle. See, this is my circle. Suppose this is my circle, and then I have a centered O here. This is the center O of the circle. O here, and then from a point P, here's a point P outside the circle like this. Point P outside the circle. Now we have to construct two tangents from point P to the circle. Now to construct two tangents from point P to the circle, what we will do is, see here, I'll do for you here. I have one circle, right? I have one circle here like this. This is the circle. I need to construct tangent. Now I have a point P here. This is the point P. From this point P, I need to construct tangent. And this is the center of the circle, that is point O. Now, to construct, this is point O from, you need to construct tangent from point P to the circle. Now to do this, what you will do is, you take the point P and make an arc from there. With that same measurement, you make the arc from point O. And you make down here also like this. Okay, after this what you will do is, after this you join the line, these two line you join like this. Okay, you join like this, these two line you join like this, you'll get a straight line. Okay, it's not straight here, you can do by yourself, it would be a straight line here. Okay, this should be a straight line, it should intersect like this and it should be a straight line like this. Okay, after this your next step is you join your PO. After joining PO, okay, let me do with straight line, let me not do randomly. Okay, this is here, you join the PO like this, PO. Here it is, you join PO like this. Okay, this is P, this is O, you join PO like this. After joining PO, what you do is, you have this one, right, like this, you have this one. Now name this point as M, you name this point as M, and then what you do is you measure the distance from P to M, you measure the distance from P to M, and then you take with your compass, and with that radius you draw a circle from M like this. You draw a circle from M. After drawing a circle from M, what you do is, okay, let me rough everything, I'll tell you again from first. See here, I've drawn a circle first, I'm doing little fast now. I'm drawing a circle first, take a point P here. After taking a point P, make arc like this from center and join your line. You join this line, that it should be a straight line. After that, this should intersect these arcs. Okay, this should intersect these arcs, means you just take a straight line like this, and then it should intersect the arcs like this, which I will make from P and O, from the center of the circle to the point P, and then you name this point, you join PO, you name this point as M, taking M as, if you measure the distance from P to M, taking M as center, with that radius you draw a circle like this, and then I'm changing the color now, you see what's the next step I'm going to do. Now you join your P to that portion where this bigger circle is intersecting the smaller circle, and join P to that portion where this bigger circle is intersecting the smaller circle on both sides. After that, you will get that this is 90 degree, and yeah, that is 90 degree, you'll get this is 90 degree, and then the tangents required here are, you name this point as O, O has already been named earlier, right? So you name this point as P and this point is Q. So P, O, P is also named earlier. That's S, PS and PQ are the required tangents. Okay, so this is the step. Now let's see here. It's given in your NCERT. Step of construction: join PO and bisect it. After bisecting, taking M as center and MO as radius, draw a circle. After that, join PQ and R, and then you will get the required tangents, that is PQ and PR, like I have done just now. Now let us see how this construction works. Now how this construction works, you just see here, it's given here. What you need to do is join OQ, you join this OQ. Okay, after joining OQ, PQO would be an angle in the semicircle. PQO is an angle in the semicircle, and therefore we can say PQ is perpendicular to OQ. Okay, PQ is perpendicular to OQ, PQ is perpendicular to OQ. Since OQ is a radius of the given circle, PQ has to be tangent to the circle. Similarly, PR is also a tangent to the circle. So, completed here. Let's see what's given here in the note. If center of the circle is not given, you may locate its center first by taking any two non-parallel chords and then finding the point of intersection of their perpendicular bisector. Okay, center of the circle does not matter, you can take directly by your compass, right? You should construct with your instrument, so you'll get from there. Okay, now we have completed this one. Okay, if you have any doubt, you can ask me. Now we'll go on to exercise number 11.2. Now we have question number 1 of your NCERT construction chapter, exercise 11.2. The question says to construct, to draw a circle of radius 6 cm, and then from a point 10 cm from its center, we need to construct the pair of tangents to the circle and measure the lengths. So let me do this question here. The question says us to draw a circle of radius 6 cm. What you need to do is you just draw a circle by your compass. You take your pin of the compass 6 cm and draw a circle. Okay, the circle would be Okay, you drew first a circle like this. After drawing a circle of 6 centimeter, this is 6 centimeter, its radius is 6 centimeter. After drawing it of 6 centimeter, you take a point 10 centimeter away from the circle. This from here to here distance should be 10 centimeter. This distance from this point to the circle should be 10 centimeter. From this point outside to the circle to the middle of the circle, that is radius, it should be 10 centimeter. This should be, let's say this point is P. From P to O, it is 10 centimeter. After that, they are telling us to construct the pair of tangents to the circle and measure their lengths. To do this, what I'll do is I will bisect P and O here and here. After that, you join your line. You join this which you have bisected straight lines. After joining that, you'll get a line like this, right? After bisecting here. After doing this, what you do is, let's name this middle point as M. You take the distance from P to M, and taking M as center, you draw a circle from M. Taking M as center, draw a circle like this. You'll get a circle, and after this, your next step is you join. You name this point which the circle is touching the smaller circle as A, and here as B. Now you join P to A and you join P to B by your scale. After doing this, you'll get the tangents required, that is PA and PB are the tangents required for this question. Completed. So here it is. They have done the same step like I have done. You can see here. First take a circle of radius 6 centimeter. Here this is the radius circle of radius 6 centimeter, and then take a point P 10 centimeter far from it. And after that, they told us to measure their lengths also, right? When you measure the length of the tangents, you will get 8 centimeter, okay? 8 centimeter each. You can measure that from your scale. Okay, this is the construction which they have done. You can see the step of construction, same as I have done, taking point A, O as center and 6 centimeter radius. After that, take point P such that OP should be 10 centimeter, and then you bisect O and P. After bisecting, you joined the line. After that, you join this one and you'll get the tangents. So the tangents are of 8 centimeter each. After here, proof is also given here. You can see the proof. Angle PQO according to this figure here. Here it is. Angle PQO here is 90 degree. So PQ is perpendicular to OQ, angle in a semicircle, and OQ being the radius of the given circle, PQ is the tangent at Q. In right triangle PQO again, OP should be 10 centimeter, OQ should be 6 centimeter. From here you will get PQ is 8 centimeter. You can prove like this, okay, that your tangents are 8 centimeter. When you measure by scale, you'll get 8 centimeter, and you can prove by this method also. Okay, this is the way. Okay, so now we shall be doing question number 2 of your NCERT of the exercise 11.2. So the question number 2 says that we need to construct a tangent. It says to construct a tangent to a circle whose radius is 4 centimeter from a point on the concentric of circle 6 centimeter and measure its length. Also, we need to verify by actual calculation. Okay, the question says to construct a tangent to a circle of radius 4 centimeter from a point of concentric circle of radius 6 centimeter and measure its length. Okay, to do this, let's see here it is given. What we need to do is, here, taking O as center and radius 4 centimeter and 6 centimeter, draw 2 circles. We need to draw 2 circles because they had said that we need to take concentric circles, right? So I'm doing in this page. Okay, we need to draw 2 circles. First you take one circle like this with radius, I'll tell you, oh, it's too big. One second. Okay, let's say this is the circle, okay? the smaller one is of radius, this is of radius 4 centimeter as it is given in the question, and the bigger one is of radius 6 centimeter as it is given in the question. Now after this, what we need to do is, these are concentric circles. After this, you see the step, taking O as center, radius, we need to draw 2 radius, right? So you name this center as O, name this center point as O. Okay, that center is called O, the center of the circle. After that, the next step is taking point P on the bigger circle, take point P on the bigger circle and join OP. Now your next step is, you just take a point somewhere here on this bigger circle P and you joined OP. Okay, you join OP like this. Join OP. Okay, you'll get a straight line. You join OP. It's a little messy here. Let me rough all this measurement. Okay, you should understand by now. Okay, fine. Let me draw the circle again. Smaller circle has been erased. Okay, this is the smaller circle, let's say. This is the smaller circle. Okay, and then this is the bigger circle, right, for us. This is the bigger circle. This is the bigger circle. From center, you draw a point P. O, this is O, this is P. You take any point at the bigger circle and join OP. Next step. The next is, with O and P as center, with O and P as center and radius more than half of OP, draw arcs above and below OP to intersect X and Y. So the next step is, you see here, from O and P you bisect, you need to bisect so that it will intersect this, O and P, and then it should be more than the radius of O and P. Means that I will make an arc here like this, below also like this. After that, you join these arcs. You join these arcs like this by straight line. Join these arcs by straight line, and then you divide this O and P in the same ratio. Here it is not same, but then you need to divide it in the same ratio as it is here. And after that, what you are asked to do is, join XY to intersect OP at M. They are telling to join XY. Okay, this is X and this is XY to intersect OP at M. It is intersecting here. This point is M. Okay, after joining XY. And the next step is, with M as center and OM as radius, draw a circle to cut the smaller radius at Q and R. With M as center and OM as radius, where is M? This M is center and OM as radius, you draw a circle. They are asking us to draw a circle like this, so that to draw a circle to cut the smaller circle at Q and R, so that it would cut the smaller circle at Q and R. You draw a circle. Okay, you draw a circle like this so that it would cut the smaller circle. Suppose this is R and this is Q, to intersect to cut the smaller circle at Q and R. Okay, you draw a circle with M as center and OM as radius. The next step, join PQ and PR. After that, you are asked to join this PQ is here, and then you join PR. Now PR and PQ are the required tangents to the circle. So we have drawn this, right? Now we need to verify it by actual calculation. Here it is. PQ and PR are the required tangents. When you measure the length of PQ, it is 4.5 centimeter approximately. Now you need to prove this by calculation, actual calculation. It is done here. Now from the triangle, you know that angle PQO is 90 degree. Where is angle PQO? You see here. Angle PQO is 90 degree. Here we know this, right? We know that angle PQO is 90 degree. So PQ should be perpendicular to OQ. Okay. From this, OQ being the radius of the smaller circle. Since OQ is the radius of the smaller circle, here you see OQ is the radius of the smaller circle. So what will happen is PQ is the tangent at Q. So PQ is the tangent. PQ is here. PQ is the tangent at Q. And what else is that? OP should be 6 centimeter. OP should be 6 centimeter. And OQ should be 4 centimeter. Let's see. OP and OQ here. OP, where's OP? OP is here. OP should be 6 centimeter. Yes, we have done that because it's the radius of the bigger circle. It's 6 centimeter. It's 6 centimeter. And OR should be 4 centimeter. We know this also. Yes. After knowing this all, we have PQ. We need to find PQ from there. You see in this figure. PQ is here. You see, it's a triangle, something like this there. This is the triangle there, and this is right triangle. Now this is P, this is O, and this is Q. Okay, there. OQ is given 4 centimeter there, and then PO is given 6 centimeter. Now from here you need to find PQ. You know that in a right triangle, hypotenuse square equal to adjacent square plus the perpendicular square, right? So from here PQ will be equal to, from that triangle which I have drawn just now, PQ will be equal to, PQ square will be equal to OP square plus OQ square. OP square minus, because it's not the hypotenuse, right? PQ is the perpendicular side. So PQ square equal to OP square minus OQ square. So you know that OP is 6 centimeter, the radius of the bigger circle. 6 centimeter square you need to write. Okay, and then OQ is 4 square, which is the radius of smaller circle. So from here we will get, what will we get? Let's see. PQ square will be equal to 6 6 are 36 minus 4 4 are 16, which will give me PQ square equal to 20. So PQ equal to root over 20. So if you find the root of this number 20, you will get, okay, let me help you solve this also. Okay, 20, how to solve this one upon root? Look here, do like this, and then let me do little above 20, and then you do like this. You know 4 4 are 16, right? You might have learned this type of division. 4 4 are 16, 4 remainder here, and then 4 plus 4 is 8. You put your 8 here. After that you put point here. After that you put 0. So 4 again. So if you put one more 0, you will get 8 something. 8, yeah, 8 5 are 5 something, you will get 4.5. You need to solve like this. Okay, after this you will get your answer, that is 4.5, which is approximately. If you have proved this, then it is proven. The question just simply tell us to do this. Okay, done. Question number 2. Okay, now we shall be doing question number 3 of your NCERT book. Okay, exercise 11.2, the chapter construction. The question says us to draw a circle of radius 3 centimeter, and then we need to take 2 points P and Q on one of its external diameter. Take 2 points P and Q on its extended diameter, each of distance 7 centimeter from its center. So, and then we need to draw tangents to the circle from these 2 points P and Q. So first we need to draw a circle of 3 centimeter radius. After that we need to take points P and Q on one of its extended diameter, each of distance 7 centimeter from its center. So let's solve this question. Okay, here it is given. So let's see the steps and let's solve. The first step is, you see here, we need to draw a circle with center O and radius 3 centimeters. So let's do as instructed. First, draw a circle of radius 3 centimeter, 3 centimeter and center O, right? After this, you draw a diameter of its extend both the side and take points. What's here? PO on the diameter such that OP equal to OQ should be 7 centimeter. What does it says is that they are telling us to take diameter of it extend. It should extend both the sides and take points PQ on the diameter such that OP equal to OQ should be 7 centimeter. Okay. Okay, now your next step is, where's my circle? Here, right? From here they are telling us to take 7 centimeter from this circle, this side 7 centimeter. It should be 7 centimeter. It should not be this much long. This much is enough. It should be 7 centimeter, and on this side also it should make 7 centimeter. Okay, this side also it should make 7 centimeter. Let's rub all this and do. Yeah, this is the center, something like this. This is the radius 3 centimeter. This is the circle. Now from this side also, wait, this is the circle. Terika. Okay, fine. Okay, let me do from first. I'll take a circle. Let me take a middle. This is my circle. Okay, and then the radius of the circle is 3 centimeter. This is the center point O of the circle. After that, we need to take 7 centimeter from here and 7 centimeter from here. This is set to us by steps of construction. After taking 7 centimeter from the center on both sides, what you do is, what does the next step says? OP should be equal to OQ. Here, let's name this as P. Let's name this point as Q. So here, OP should be equal to OQ should be equal to 7 centimeter. Fine. And then draw the perpendicular bisector OP and OQ to intersect OP and OQ. Okay. Next step is to draw perpendicular bisector. Okay, where is it? From O and P, you draw perpendicular bisector. Okay. O and P, you draw perpendicular bisector here also, so that it would intersect O and P at certain point somewhere here like this. And here also O and Q also you draw perpendicular bisector so that it should intersect O and Q somewhere middle. Somewhere in the middle. It's not middle here, but then you need to understand that it should be in the middle. After that, okay, where is it? Yeah. After that, you name these points as, let's do the same as what has been done here, M and N. Okay, I'm naming this point. Change the color. This point is M. This point is M, and this point is N. After that, you take OM as center and OM as radius and M as center. Draw a circle. It's not a circle, but it should be a circle. Okay, you need to draw by your compass. And then again, taking NQ as radius and N as center, draw a circle like this. Fine. Draw by your instruments, okay? Not by hand. I'm doing it by hand. After that, yeah, they have told us same to do here. Okay, after that, join PA, PC, QB and QD. Let's see. PA, where is PA? Okay, what are the naming here? PA, A, B, C, D. Okay. This is A, okay. This is B, this is C, and this is D. Now your next step is, you need to join PA, you join PC, you join QB, and you join QD. After this, what they had told us to do, let's see. After joining all that, these four are the required tangents: PA, PC, QB, QD. PA, PC, QA, QD are the required tangents. QB, I guess. Yeah, QB, QD are the required tangents. Now to prove these, first you measure the length of tangents. You will get 6.3 centimeter. And after that, you have to do this proof. To do this proof, it's here. Okay. To do this proof, what you need to do is, you see here, to do this proof, right? Angle P, you see here, to do this proof, right? Angle PAO should equal to angle QBO. Where is PAO? Angle PAO, angle P, which was what's given? Angle PAO and angle QBO. Okay, fine. QBO, see in this figure. QAO and QBO are 90 degree here. Do you agree with this? You need to agree, right? It's 90 degree. So PA should be perpendicular to AO. So from here, PA should be perpendicular to AO and QB should be perpendicular to BO. Agree with this? After this, again, the next step is, since OA and OB are the radii of the given circle, PA and QB are the tangents. OA and OB are the radii, so PA and PB are nothing but they are tangents, right? And in triangle PAO and QBO, PAO and QBO, let's see what are the things in this triangle. Triangle PAO and triangle QBO. Let's see what's happening in this triangle. Here, OA should be equal to OB should be equal to 3 centimeter. We know this, and OP should be equal to OQ should be equal to 7 centimeter. Right? And you know this, right? And then you know this. After this, you need to take the Pythagoras theorem again. PA square equal to OP square. Let's see. PA square equal to OP square. In this triangle, that is in triangle PAO, you take Pythagoras theorem, it would be PO square will be equal to PA square plus OA square. Now from here we need to find PA square. PA square will be equal to PO square minus OA square. Right, let me do above here. You can see here, right? Now PA square would be equal to PO. What's the measure of PO? It's 7 centimeter. 7 square minus OA is 3 centimeter, 3 square. So PA square will be equal to 7 7 are 49 minus 3 3 are 9. I got PA equal to root over 49. Is it fine? I got root over 49. Oh, I got 49. It's only root over 40 because they are minusing, right? Yeah, I was summing up. It would be root over 40, okay? Root over 40. I got root over 40. And when you solve this, you will get 6.3 approximately. Again, you take another triangle. Again, I'm taking another triangle, that is here. Take triangle QBO. You can take triangle QBO from here. When you take triangle QBO, here the hypotenuse is OQ square will be equal to OB square plus BQ square, and we need to find BQ square from here, that is the perpendicular. BQ square will be equal to OQ square minus OB square. So find, let's do above here. It would give us what it would give us. BQ square will be equal to OQ is 7 centimeters. So 7 square 49 minus 3 square, that is 9. Okay, 3 square, that is 9, and 3 square, that is 9, and you got BQ equal to root over 40, which was same as before, and you got your answer 6.3 approximately. So hence we have proven. Okay, you need to measure the tangents by your scale first, a ruler first, and then you'll get same as this. If you got same, then you have proved your construction. Thank you. So now we have question number 4 of your NCERT book, your chapter construction, right? The question number 4 says us to draw a pair of tangents to a circle whose radius is 5 centimeter and they are inclined to each other at an angle of 60 degree. Right, we need to draw a circle. First draw a circle of radius 5 centimeter, and we need to draw a tangents which are inclined to each other at 60 degree. Means this tangent should be inclined to each other at 60 degree, right? So let's do here. It's given here. Let's follow this step and do. With OS center in 5 centimeter as radius, draw a circle. Okay, let's do this first. Draw a circle. Okay, draw a circle. Draw a circle. This is the circle. Radius is kitna centimeter? 5 centimeter. It's given in the question. Draw a circle with radius 5 centimeter. And take a point A on the circumference of the circle and join OA. Now take a point A, suppose here on the circumference of the circle, this is point O, and join OA. After joining OA, draw AX perpendicular to OA. Just draw AX which is perpendicular to OA. You draw. Oh, my circle is little. Okay. I need to draw my circle little this side, right? Shall I do? Yeah, I'll do again. Rubbing. Draw a circle. Radius is 5 centimeter as given in the question. Radius is 5 centimeter as given in the question. This is O. Now take a point A on the circumference of the circle and join OA. After that, from A, you draw a perpendicular on OAX. You draw AX which should be 90 degree on OA. As this said to us by step of construction. And construct angle AOB which should be 120 degree. After that, you construct this angle AO. What was it? Angle AOB which should be 120 degree. See here. Rubbing this one, okay, this part. Now from A, they are telling us to draw B here. This is the center point O, and we need to draw A such that, not A, draw B here such that they should be 120 degree. 120 degree, and after this, you know how to draw 120 degree by your compass, right? This is your scale. You keep a point here and you draw an arc this side like this. From here you take an arc here, this, and you join this one. It would be 120 degree. Fine. It's very simple. Now after this, what's next? Where B lies on the circumference. B also lies on the circumference. Draw BY perpendicular to OB. After that, you draw BY which should be perpendicular to OB. It should be perpendicular to OB. It should be 90 degree. This is also 90 degree. And the next step is both AX and, look here, both AX and BY intersect at this point. Let's name this point as Q. And next step is PA and PB are the required tangents. So after you have done this, after you have followed the same procedure, you will get this angle as 60 degree. Fine. But you need to follow the procedure. You'll get this angle AQB as 60 degree. Hence, with what has told us to draw in the question. To do in the question. Yes, this is 60 degree. So from it proof, you can write this. Angle OAP will be equal to 90 and angle OBP is also 90, and by construction angle AOB is 120 degree. In quadrilateral OAPB, as you can see, angle APB will be equal to 360 degree minus angle OAP plus angle OBP plus angle AOB. In quadrilateral, this 360 degree angle APB should be equal to 360 degree because the sum of all sides should be 360 degree, right? So of quadrilateral. So to find angle APB, and then 360 degree minus all these angles will give us 360 degree minus 300, because when you add all these, that is 90 plus 90 plus 120, you'll get 300, and when you minus 360 from 360 from 300, you will get 60 degree. Hence we have proven. Okay, now we shall be doing question number 5 of your NCERT book with the chapter construction. The question number 5 says us to draw a line segment of length 8 centimeter, and then taking a, we need to draw AB, okay, and taking A as center, we need to draw a circle of radius 4 centimeter, and taking B as center, another circle of radius 3 centimeter. Then we need to construct tangents to each circle from the center of the other circle. So let's see how to do this. It's very simple. First, let me do what they had done, what they had told to do. We need to draw a line segment. Let me draw a straight line. Straight line, a little smaller, this much. Okay, this is A and this is B. Line segment is of 8 centimeter line. Taking A as center, we need to draw a circle of radius 4 centimeter. Okay, from A, something like this. Okay, A as center, draw a circle of radius. Okay, wait, let me do. Okay, this is the circle. Taking A as center, draw a circle of radius. This radius of circle is 4 centimeter. From A, this radius is how much centimeter? 4 centimeter. And from B also, you draw, it's taking B as center, you draw a circle. Okay, this should be of radius 3 centimeter. Radius should be 3 centimeter. And then we need to construct tangents to each circle, to both this circle from the center of the other circle. Means, let's see here. Draw AB equal to 8 centimeter, which we have done, right? After drawing AB of 8 centimeter, with A and B as centers, we have drawn radius respectively, and between, after that, as we have drawn 2 circles, right? Now after that, the next step is draw the perpendicular bisector of AB, intersecting AB at O. We need to draw perpendicular bisector of AB like this, okay, and then it should intersect AB at some point like this. Let's say this point is O here. After that, with O as center and O as radius, draw a circle which intersect the 2 circles at PQRS. Now the next step they had told us to do is, with O as center and OA as radius, they had told us to draw a circle. Okay, they had told us to draw a circle with O as center and OA as radius. This is the circle, let's say. And then let's name this point where it meets this circle is P, this one is Q, this one is R, and this one is S, as it's there in the step of construction. And we need to join. Now joined BP and all. Let's see. Where is B? You join this BP. B is here. Which color shall I use? Purple. Okay. You join BP, you join BS, you join AQ, and you join AQ? No. From here. AQ, and you join this one. AR. It's here. After joining, BP and BQ are the tangent from B to the circle with center A. Okay, now after this you have got your tangents, that is from here AQ and AR are tangents from this circle with center A, and BP and BS are tangents. Okay, fine. Now proof is given here. You can see from this figure that angle APB should be equal to angle AQB. These both are 90 degree. Since they are 90 degree, they are AP is perpendicular to PB and AQ is perpendicular to QB. Therefore, BP and BQ are tangent to the circle with center A. Similarly, AR and AS are tangent to the circle with center B. Here they are using different alphabets, and I have used different here. You can use any alphabet, does not matter. Okay. Now we shall be doing question number 6. Fine. Okay, the question now is question number 6. The question tells, let's read the question. Let ABC be a right triangle in which AB is 6 cm, BC is 8 cm, and angle B is 90 degree. BD is the perpendicular from B on AC. The circle through BCD is drawn. Construct the tangents from A to this circle. Okay, now this is the question. Now let's do how to do this. First, I think we need to construct triangle, right? Draw BC equal to 8 cm. Okay, BC equal to 8 cm and draw the perpendicular at B. Cut BC equal to, okay, let's first obtain the triangle ABC. To obtain the triangle, take BC. It takes a line. This is BC. Fine. This is B and this is C. The length is how much? 8 cm as given in the question. Now from B you make 90 degree. I have taught you to make 90 degree many times. So you see here, draw a ray like this here, and then from here you make an arc here. What you need to do is, look here, after doing this, from this point and this point make an arc here, and you join your B to that point. You'll get a straight line which is making 90 degree. It is the 90 degree. Okay, they had told us to make angle B as 90 degree, right? So angle B is 90 degree. And what else? From here, AB, you take A somewhere here. AB should be 6 cm. You measure by your scale and you join this AC. Fine, join the AC like this. Fine. After this is your required triangle. Now once we have got the triangle, what we need to do is draw BD perpendicular to AC. After we have got triangle, draw BD which will be perpendicular to AC. Just draw BD from B which will be perpendicular to AC, exactly 90 cm. Fine, exactly 90 cm. And what else does it say? BD perpendicular to AC. After that, since BDC equal to 90 degree and the circle has to pass through B, C and D, BC must be diameter of the circle. See here, since angle BDC is 90 degree and the circle has to pass through BC and D. It's given in the question. Since angle BDC is 90 degree and circle has to pass through BC and D as given in the question, BC should be the diameter of the circle. Fine. BC should be the diameter of the circle. So take O as the midpoint of BC and with center O as center and OB as radius, draw a circle. Now you mark some point. I'm rubbing everything now because it's too messy here. Here. Okay, look here. You mark some points. You mark some point on BC, that is O. After that, taking O as center and OB as radius, draw a circle which should cut at B, C and D like this. Draw a circle. This is not a circle, but you need to draw a circle like it's given here. Draw a circle. After drawing the circle, what you are asked to do is, where is it? Yeah. After drawing the circle, to draw tangents from A to the circle with center O. Now we need to draw tangent from this A to the circle at center O. Now to do that, join OA and draw its perpendicular bisector to intersect OA at E. Now joint OA, you are asked to join O and A here. Join O and A and draw its perpendicular bisector to intersect OA at E. Now you draw its perpendicular bisector like this. Draw its perpendicular bisector like this so that it would intersect this like this. Okay, so that it will intersect OA at E. This is the point E. It should intersect at E. After that, with E as center and E as radius, draw a circle which intersect the previous circle at B and F. Now, with E as center and E as radius, you draw the circle so that it would intersect the previous circle at B and F. It should intersect the previous circle at B and B is here, and F. Where is our F? Yes, F is there. Okay, this is F here. It should intersect the previous circle at B and F. This my circle is not appropriate, so I'm a little confused. Let me teach you from here. Okay, so it should intersect this circle. Yeah, with E as center and E as radius, you draw a circle so that which intersect the previous circle at B and F. B is here and F is here, right? B is here and F is here, so that it would intersect the previous circle at B and F. After this, you join A and F. A is here and F is here. You see in this figure, A is here and F is here. You join AF. After that, AB is here and AF are the required tangents which we were asked to do. Fine. For here, it's little messy here. Okay, it's difficult for me to explain from here because I have drawn random circle, right? So let me clear this page. Fine. So here we have now to prove angle ABO. Angle ABO should be equal to angle AFO should be equal to 90 degree, and they are perpendicular. Hence AB and AF are tangents from A to the circle with center O. Fine. So now we shall be doing question number 7 of your NCERT book. The question says us to draw a circle with the help of a bangle. Okay, you know what's bangle, right? Chudi. Take a point outside the circle, and you take a point outside the circle. After that, construct the pair of tangents from this point to the circle. Okay, we need to draw a circle with the help of a bangle and take a point outside the circle, and you construct tangents, pair of tangents from the point outside the circle. Fine. Now let's see what's the step here. We'll follow this step and solve our question. Step of construction. Draw a circle with a bangle. You just draw a circle. Let me do here. Draw a circle with a bangle. Fine. And to find its center, draw any two chords of the circle, say AB and CD. To find the center, what you do is, this is the circle, right? I have done randomly again. Okay, this is the circle, right? Now you draw two chords. Here one, here one. Fine. You draw two chords, and this is done to find the center. Okay, let's name them A, B, and CD. This is A, this is B, this is C, this is D. Fine. And draw the perpendicular bisector AB and CD to intersect at O. After that, you draw the perpendicular bisector for AB and CD so that they would intersect at O. Fine. Now to do this, what you need to do is change the color red. Okay, let's see here. From point A, make an arc. From point B, make an arc. From point C, make an arc. From point D, make an arc. You join this line like this. Okay, I've done randomly, and you'll get a point O here, which is your center. Fine. After that, now O is the center of the circle. Fine. Since the perpendicular drawn from the center of a circle to any chord bisects the chord and vice versa, we know this. So to draw the tangent from point P outside the circle, take any point P outside the circle. You take any point P outside the circle. Okay, let's take it here. Point P. Fine. And draw the perpendicular bisector OP, which meets OP at ODES. And you draw the perpendicular bisector OP at PDES. Okay, you draw the perpendicular bisector here again like this. Let me change the color yellow. Okay, you draw perpendicular bisector and it will join this. Okay, you join this line and you join OP. You will meet at this point. This point is named as PDES. Okay, this point is named as PDES. And it's named ODES. It's fine, I've written PDES, there is not any problem. With ODES as center and ODES as radius, draw a circle which cuts the given circle at Q and R. Now, with this P as center and PDES as radius, you draw a circle. Okay, and it should cut the given circle at which point? Q and R. Let's name this as Q and let's name this as R because they had said that it would cut on Q and R. Now, the next step is, here it is, join PQ and PR. You are asked to join PQ. PQ is here. Let me do with PCon. Okay, I'm doing with red color. You join this PQ and you join this PR. It's not exactly here, but then you join PQ and you join PR. Fine. After that, what you are asked to do is, you are you have just to prove, and PQ and PR are the required tangent. This PQ and PR are the required tangents. So PQ and PR are the required tangents, and here is the proof. An angle OQP equal to angle ORP, they are 90 degree, fine. And then OQ is perpendicular to QP and OR is perpendicular to RP. Hence PQ and PR are the tangents to the given circle. Hope you understand, right? So we have completed with this chapter. Question number 7 also we have completed with the chapter construction. Fine. So from the next video we'll start from the chapter that was application of trigonometry, I guess, from the chapter that is in my portion. Till then, if you didn't understand anything, you can ask me in the comment section in the YouTube also, and also in this one privately to me. Okay, you can message privately. Okay, thank you.